Hello students. So today we will discuss about the dilution formula, and afterwards we will discuss about our all the topics which we have covered so far. Means there will be a quick revision in today's session. Okay, so quickly we will discuss about the dilution formula. So first of all, let us discuss what is dilution actually. Dilution means nothing but the addition of water. That is nothing but that is the addition of water. What we are doing, I have two sample over here. One sample I am already shown that this is a solution of 100 ml. This is a 100 ml solution. Ml hai, so it means it is a volume. That is the volume. In this particular solution, the amount of the solute is 10 gram. Means the concentration of solute is 10 gram. It means the number of moles of solute we can easily calculate it if we know the formula of solute. Let us consider it is any solute. We are not bothering about the solute. We have to focus on the concentration. With the help of concentration, we can easily calculate the number of moles. Okay. So in formula we are having the moles. So that's why we are not talking about the which solute we are adding. Just focus on the concentration. Okay. Now we dilute it. Okay. Let's add. We are adding 100 ml of the water into it. As we are adding 100 ml, the volume of the solution become now 200 ml. Is there any impact of solute? The concentration of solute will change? The answer is no, because we are not adding solute anymore. We are adding water into it. So the volume will increase, but not the solute. The concentration of solute become same. So that is exactly, I have already put question mark over here. So just think it of what you are thinking. That is exactly right. That is equal to 10 gram. That will never change because we are not adding solute. So what we are having now, what is the final conclusion? The conclusion is this: on adding water into the solution, the solute concentration will never change. I am repeating it. After the dilution, in other way we can say, after the dilution, the solute concentration will remain constant. Okay. After the dilution, the solute concentration will remain constant. So I am already writing it up. The number of solute particles, number of moles of solute particle will be constant on dilution. Fine. So that is the result over here. So what is the final conclusion? So we are move ahead for the final conclusion. That is, this is the formula of molarity. Molarity means what? The number of moles of solute divided by volume in the volume of the solution in liters. So from here, can we calculate the number of solute? Number of moles of solute. The number of moles of solute will be molarity into volume. Okay. So in other way we can say M into V. We can calculate it M into V. Write it up, M into V. Molarity into volume. So number of moles of solute. We have other formula of calculation of the number of moles of solute, that is molarity into volume. Whatever the molarity of the solution, multiplied it by the volume, you will get the number of moles. Okay. So here one more thing I am writing. From here, this part is constant. So if I am omitting the constant part, the relationship which we can draw in between molarity and the volume is this: molarity is inversely proportional to the volume. Just take care carefully. The molarity is inversely proportional to volume. As the volume increases, molarity will become low. As the volume decreases, molarity will high. So we have two sample over here. Okay. So in first sample, the volume is 100 ml, and in other sample the volume is 200 ml. So from this formula, the volume is high, molarity will be less. So molarity is less over here because the volume is high compared to this. So here the molarity will be high. Lesser is the volume, higher will be the molarity. Higher is the volume, lesser will be the molarity. Done. and say this is the first sample and this is the second sample. So we just give a normal abbreviation, that is M1. Say M1 is the molarity of this solution and V1 is the volume. As we know the volume, but just take give the V1 over it. Then other one is, say M2 is the molarity and we give V2 as the volume. And we know that this is equal to M1 into V1 will become the number of moles of solute. This is the number of moles of solute and this is also the number of moles of solute. So in particular case we can say number of moles of solute and number of moles of solute will never change. So finally, what is the conclusion now? The conclusion is this: M1 V1 will be equal to M2 V2. So this is the molarity equation. This is called the molarity equation and has lots of its importance. It's very important formula. Very important formula. Just take it carefully. We are considering M1 is the molarity of this solution and volume is V1. Here V1 is the 100 ml. Okay. So M2 is the molarity of this one. Molarity of M2. M2 is lesser than M1. Why? Because the volume is greater. Here the volume is lesser. So that's why. So M2 multiplied by V2. So both are number of moles. Both are number of moles. We have already discussed the number of moles are equal. They will never change. So M1 V1 is equal to M2 V2. So this is the final conclusion we are having. That is called the molarity equation. The same equation is true for the normality. That is M1 V1 equal to M2 V2. That is also true. We can also prove it by the same way. So you just remember both formula M1 V1 is equal to M2 V2 and N1 V1 equal to N2 V2. Thank you. So let's take a quick revision of the chapter. So we have covered so far. So first of all, this is the first topic and the name of the chapter, that is called solution. So what is solution? We have covered three terms in this definition of the solution. That is called it is a homogeneous mixture and the components are non-reactive. They will never react. Like solution is made up of two components. One is solute and another one is solvent. Take a quick revision. Okay, so they will never react with each other. Solute and solvent will never react with each other. It is a mixture. Mixture is homogeneous. Okay, homogeneous means the composition throughout the mixture is same, like salt in water. The composition of the mixture is throughout same, and they will never react with each other. They are non-reactive. And limit of the addition, we can add solute into the solvent in a variable amount, in a vary amount. Okay, we can't add as much as possible. So there is a limit of the addition. So that is all about the solution. Now we will discuss about the concentration term, which is also considered to be as the backbone of this chapter. Thank you. So here is the second part, that is called the concentration terms of solution. This is the concentration term of the solution. In concentration term, we can divide the concentration term into two parts, that is the type 1 concentration and type 2 concentration. Till now we have covered the type 1 concentration. In the second session we will start type 2 concentration. It is quite easy compared to this. And here is also 4 concentration and 4 concentration. Total there are 8 concentration. On what basis they can be divided? Very simple. This is temperature dependent. This is temperature dependent. If it is temperature dependent, then it will be temperature independent. That will be temperature independent. Why it is temperature dependent? Because we can see in the denominator you will always have the volume, and volume and the temperature there is a relationship. In +1 we have already discussed about this relationship between temperature and the volume. Okay, so here there is a no relationship. We can find either volume or the numbers of moles. the number of moles. So number and mass will never change by changing of the temperature. So we can say this is the mass dependent of volume dependent, also this concentration, also the volume dependent, and these are the mass dependent, mass or temperature independent, we can say. So first of all, let us discuss one by one. I'm just giving you the quick review of the concentration term. The first concentration term is percentage by volume. We can say the V by V. V by V means of the upper term will be of solute and the denominator term will be as a solution. Remember it will be solution, not solvent. So this is solute divided by solvent. The same way my percentage weight by volume, the upper term is weight. I am writing 2 or 3 things which you have to consider everywhere, where if V is there, it means it is nothing but this is the volume, and if volume is there, the thing will be always liquid. That will be the state of this is liquid. If the W is there, then we are talking about mass, and mass means something solid is there. Done. So volume and V and W means that. And one more thing which we can use, that is the number of moles of solute or number of moles of solvent. These are the number of moles. We are talking about the numbers because in this we will use the numbers. So just remember these 3 abbreviations. These are very important. V for volume, W for mass, and N means number of moles. It can be solvent and it can be solute. So here is we are discussing about the type 1 concentration. So in type 1 concentration we are talking about percentage by volume, percentage weight by volume, W by V, molarity, and the normality. We have already discussed these 4 concentration, and till now we have covered our type 1 concentration. Afterwards we will start our this one type 2 concentration, and before this we will have a quick review or quick revision of all 4. So one by one we will do this. So just take a overview of the type 2 concentration. The percentage by mass, as we can see, W by W means both are in solid. Our solution is also solid and our solute is also solid. Molality, it is molality. Again I am talking, it is molality and this is molarity. Both are different. Both are different. In this chapter we should concentrate the important part of the concentration term. The one is molarity and the second one is molality and the mole fraction. These 3 we are talking again and again about these 3 concentration terms, that molarity, molality and the mole fraction. So 2 are there in which we will study in the type 2 concentration, and here we have already discussed about the molarity. Even today we discuss about the molarity equation, M1V1 is equal to M2V2. So we will discuss it one by one. The molarity, normality, percentage by mass, molality, mole fraction and the parts per million. I have already given the one question in this type of concentration, like fluoride ions. Okay. In toothpaste we are using 1 ppm fluoride ion, 1 ppm of fluoride ion. So let's discuss one by one about the type 1 concentration. I am just talking about the definition and the formula. Thank you. So this is the first concentration term of type 1, that is called the percentage by volume. Percentage by volume is denoted by V by V. As I already told you, the upper V will denote the physical state of solute and the lower V, yani lower part is denoted the physical state of solution. Means both are in liquid, volume dissolving volume. Like the simple example is this, say alcohol plus water will make the solution. Okay, so the same thing, both are in liquid form. Alcohol is also in liquid and water is also in liquid form. So we are talking about the percentage by volume. Percentage by volume, what will be the definition? The volume of the solute. We are talking about volume because it is in the volume. The volume of the solute dissolved in 100 ml of solution, dissolving 100 ml of solution. So the formula will be, so the question mark is for you. So what will be the formula? Think it of and make the image in your mind and just check it out. The formula of the this one is percentage by volume, that will be volume of solute divided by volume of solution multiplied by 100. So here is the question is how we can calculate the volume of the solution by adding volume of solute plus volume of solvent, because both are in same quantity, so we can add easily. Okay, you can easily say this is 10 ml and this is 90 ml, so we can easily add this and the solution will be 100 ml. We can add it because both are in the same quantity. Thank you. So here is the second concentration term of type first. So that is percentage mass by volume, that is W by V. Same way में that will be the solute, the physical state of solute is solid, and this is the solution, the volume is NAD, that will be in liquid form. The example of this is very simple. Say the salt is in solid form dissolved in water. Salt dissolved in water will be the example of this is. So the mass of solute present in 100 ml of solution. So that will be the definition of this concentration term. Why we are using 100 ml? Because this is the percentage. So multiply by 100 is there for the calculation of the percentage. Remember it. So percentage W by V will be equal to weight of the solute divided by volume of the solution multiplied by 100. The thing is that how we can calculate the volume of the solution? Is volume of the solution equal to, here we are having weight of solute plus volume of the solvent. The answer is no, we cannot add this thing directly. So for this reason we require density. Density means mass by volume. We have to calculate the volume of this. So how we can calculate the volume? This implies volume will be equal to mass by density. So by this way we can calculate the volume of it. Remember it, without density this thing cannot be calculated and cannot be added. Hello friends, so this is very important concentration term. This is the third concentration term of type first, and as I told you, this is very important concentration term. This concentration term contain lots of numerical portion and use again and again in the chapter, not in even solution, everywhere we are talking about the molarity. So molarity has lots of its importance, so do it carefully. Molarity. So here is the formula of the molarity. The molarity denoted by capital M, the number of moles of solute dissolving per liter of the solution. I am talking about liter of the solution, but usually in lab we are not using the solution in liters, so we will convert into the milliliter. So let's change some formula. The number of moles we can also use N solute. So this is the number of moles of solute divided by volume of the solution. Say volume of solution, that is in liter. And we also know that the number of, how we can calculate the number of moles, the given mass divided by molecular mass. So change it. Now we are also writing it. The number of moles can be writing weight of the solute divided by M, molecular mass of the solute, multiplied by volume. If it is in ml, volume of solution I am talking about, multiplied by 1000. So final volume will be, molarity will be equal to weight of the solute divided by molecular mass of the solute multiplied by volume of solution in ml multiplied by 1000. So this will be the final volume of the final formula of the molarity. So from here, what is the unit of this? This is the moles, that is the number of moles. So the unit of number of moles is moles itself, moles by moles per liter. So unit of is moles per liter. I think this part we did not cover, so just remember it. The unit of the molarity will be moles per liter. So this is very important, and lots of numericals are there. Even today also we have covered about the molarity equation. So what will be the molarity equation? Also discussed about the molarity equation. So molarity equation will be M1 V1 equal to M2 V2. This formula is also very important formula. So what is M1 V1? That is the number of moles of solute. On dilution, we discussed that number of moles of solute will never change, so this is also the number of moles of solute. So this is basically the dilution formula. So take care of it. The dilution formula, the number of moles of solute will never change. That's why the M1 V1 is equal to M2 V2. Thank you. Hello friends, so this is the fourth concentration term of type 1, that is called the normality. It is denoted by a capital N, and the formula will be the number of gram equivalent of the solute. So this is the new term, so remember it carefully. That is the number of gram equivalent of the solute. The number of gram equivalent divided by the volume of the solution. So what will be the definition of the normality? So definition of the normality will be the number of gram equivalent of the solute dissolved in per liter of the solution. Again, you may see that volume comes in the denominator, so this is the type 1 concentration. So how we can calculate the number of gram equivalent? Number of gram equivalent will be equal to given mass divided by equivalent mass, and there are so many different ways to finding the equivalent mass. Just go through with the table. For acid, there is a different formula. For base, there is a different formula. For elements, also there is a different formula. So just go through with the table to calculation of the equivalent mass. Fine. So what will be the formula? We will write the formula, exact formula for the normality, which we are using again and again. So the formula will be N will be equal to given mass, that is the weight of the solute divided by equivalent mass multiply by volume of solution in liters. If it is in ml, then multiply by 1000. So this is the basically the exact formula for the normality. Same way we can say that if the molarity has its molarity equation and normality has its also normality equation. Fine. Apart from this, two more formulas are also there. If the solute is not same, that will be different. In this particular case, the solute is same, but if the solute is not same in both the cases, so one more formula you may also remember, the second formula. So this is the first formula. It will be N1 V1 plus N2 V2 will be equal to N3 V3, where V3 equal to V1 plus V2. The same way we can use it for the molarity as well. For the M1 V1 plus M2 V2 will be equal to M3 V3, and V3 will be nothing but V1 plus V2. So this is the final revision of the type 1 concentration. So in the next session we will discuss about the type 2 concentration. Thank you.